Hi folks, Matt Lanham, Regional Sales Manager from Cambridge Engineering. You know, sales reps are often asked to defend how a Cambridge space heater just works better than anything else out in the market. And, you know, frequently the contractor and the building owners are not engaged in why something works better. They're more interested in how to get the job done for less money. Today we are going to take a few minutes to review some topics in thermodynamics and the engineering principles behind why our heaters work better, specifically convective heat transfer. Please feel free to share this information with your fellow sales reps, contractors, and engineers in your territory, and please follow up with your Cambridge Regional Sales Manager if you have any questions whatsoever. Thank you.
Let's start out first by talking about a ventilation-only system. Cambridge heaters can be utilized as both ventilation and heating systems. Unique in the fact that Cambridge heaters utilize a blow-through design and 100% outside air, we are able to achieve 160-degree temperature rise and discharge temperature. No other manufacturer in the industry is able to achieve 160 degrees. Why? Our patented stainless steel burner design and the position of the blower relative to the burner. And this keeps our mechanical components out of the hot air stream where they tend to degrade quicker due to excessive heat. So as a ventilation system in this example, the heating unit can temper the outside air, delivering 70-degree discharge at a low velocity. This takes care of the air load of a given building in this example, which can account for 30 to 70% of a given building's overall heat load. By turning up the output of the very same heater, given proper unit placement and sizing, we are able to meet the needs of both the building's air load and the conduction load. All this is done while utilizing the very same CFM input as in the ventilation mode. So what does the position of the blower mean to our design? The blower in the cold air stream produces a higher mass flow rate. Draw-through systems produce a lower mass flow rate because air is less dense at higher temperatures. Determining the total heat load, in this case, using direct fire technologies can be expressed as the following. We cannot utilize a simple correction factor of 1.08, and it's so widely used in our industry because we are not dealing with standard temperature, nor are we dealing with standard CFM conditions. Looking at the mass flow rate, using a constant volume fan in both a draw-through and a blow-through design, assuming 0 degrees outside temperature and a maximum temperature rise of 120 degrees. For the draw-through unit, the air density at the fan for a draw-through unit is 0.068 pounds per cubic foot. A blow-through fan processes more dense air at 0.086 pounds per cubic foot. This increase in mass flow alone allows the Cambridge unit to produce 26% more mass per fan CFM, which accounts for 26% more BTUs per hour for every CFM. Looking at the discharge temp now, draw-through units produce a maximum discharge temperature of 120 degrees, despite claims in the industry. Our blow-through units deliver a maximum discharge temperature and temperature rise of 160 degrees. This additional 40 degrees of discharge accounts for 33% more BTUs per hour for every CFM simply due to the discharge temperature. When we take into account mass flow and the discharge temperature, our increased mass flow of 26% and the increased discharge temperature of 33% into our convective heat transfer equation, we transfer 68% more BTUs per hour for every CFM processed by a constant volume fan. What does this mean to you as far as the conduction load? We've handled the air load already. Every degree above a building space temperature is now usable for conduction losses, and these are called usable BTUs. Using a space temperature of 70 degrees with an output temperatures of 120 degrees versus 160 degrees, Cambridge heaters deliver 80% more usable or net BTUs for every CFM. And this is huge. Using the same mass flow data the same discharge temperature produces 127% more or net usable BTUs per hour for every CFM processed by a constant volume fan.
These properties alone are important elements to uncover how HTHV technologies are far superior to any other heating product in the market, and helping our contractors and engineers understand that we cannot measure performance solely by BTU ratings is key to providing them with the right technology with the performance they desire. As always, partner with your Cambridge regional managers and help set up lunch and learns and contractor education sessions for the people in your communities. Thank you.